Hosting provided by Host Tornado. They offer website hosting packages, dedicated servers, and VPS solutions. Host.t.net.
Programming Throwdown, Episode 30, FPGAs. Take it away, Jason.
Hey, so, I'm a big fan of board games, as is Patrick. And, been playing a lot of board games lately on the phone.
So you mean like Monopoly?
Actually, do they have Monopoly? Oh, no, you know what? I looked into Monopoly on the phone, but it got terrible reviews. Like, a bunch of people were like, the app crashes. There's, like, microtransactions in Monopoly, which blows my mind.
That sounds horrible.
Yeah.
No, I was joking.
Yeah.
Most people think board games, Monopoly, not good. I don't like board games.
Yeah, that's right. That is sort of the flow. It's like, let me think. Board games equals Monopoly equals me sitting around for 3 hours while the two people left, finish the game equals not fun. But, yeah, so I've been playing Ticket to Ride. It's been pretty awesome. Patrick's been playing Carcassonne, or Carcassonne, depending on...
I won't try to pronounce it. Yeah, I play several board games on my phone. I like this card game, Dominion.
Oh, yeah, Dominion's great. I didn't know they had that on the phone.
And you can play it really fast. I don't know, I have an iPhone, so I can play it on my iPhone.
Oh, I see. Is Dominion, is it free?
Yeah, well, I have a version I downloaded a long time ago that was free. Supposedly, the guy was going to stop doing it when they actually released a real Dominion, but I don't know if that's ever happened.
That they've released a free one, or that he...
So they were going to make an official, the people who would officially license Dominion.
Oh, I see. But they haven't done that yet.
Yeah, I don't know if they did.
Gotcha. Yeah, they're really fun. I mean, it's the bad thing about Ticket to Ride is so you can either do pass and play, which I've been doing with my wife, where like, you use a tablet and I put some trains down and I pass it over to her, right? The online play, it forces you to play with strangers, which I think is a terrible design decision. I mean, I think the problem is, you think about it, right? Who makes a board game? Somebody who is like pretty into like math, techie, like game theory kind of stuff, or whatever. Those people, would never want to play with friends. They'd always want to play like ranked. Like that's what they have, is like this ranked game system where I'm being matched up with somebody from a pool of 3 people probably who want to play Ticket to Ride. I'm being matched up with...
You should mention this is only on Android. On iOS, you can actually play with your friends.
Really?
Yes.
Oh man. Yeah. So specifically, the Android is literally a copy of the web version. So yeah, they're using like, how Adobe has this thing called Flex. I think it's called Flex or Air or something like that.
Air. Yeah.
Air. Yeah, where you write code and it works on the web and on the phone. So these guys are using that, I believe. And yeah, so on the web as well, you can't pick people to play against.
So for all the people who are extremely confused about Jason talking about putting trains down on a board because you don't know what this Ticket to Ride game is, it's a board game that they made an iPhone or now an Android version of, and they also have an iPhone, iPad version, iOS version, and a web version apparently, which has been out for a while. So how do you like playing? So do you have the board game, the actual board game?
No, so I used to play board games with a group of guys back when I lived on the East Coast, and we all kind of split the cost by buying different board games each, and so I did not have the Ticket to Ride game, and I still have
okay.
Yeah.
But you have played the physical version.
Oh yeah, a bunch of times. Have you do you have that Ticket to Ride?
I do. I have the Ticket to Ride.
I was amazed how mainstream Ticket to Ride is. Like, it's in Walmart.
Yeah, they sell it in
Target now. Yeah, it's amazing.
That's right. So how do you feel like the differences between playing it on a tablet phone versus actually moving the pieces and sitting around a table?
Yeah, so for all of these board games, it is way better on the phone, on electronic version. I'm just so much. I mean, it's almost to the point where, if they made tablets just a little bit bigger, I would just play it on the tablet, like even with a group of 4 people, rather than...
Really?
Yeah,
because I find it depends on the game. Yeah, so but Ticket to Ride isn't that much upkeep and like rules and math that you have to get right. So I actually prefer playing it in person, I think. And people have more fun and conversations. When you play on your phone, even if with people in the same room, like everybody's like really focused and like trying to do their thing. And so it gets kind of quiet. People don't tend to converse as much. But then other games that I've played that require, like Dominion, I was saying, there's like a lot of shuffling you have to do and stuff. So it's actually really nice on the phone because they just do all that for you. So you can just play very quickly. So you can get a game in against a computer or a random person or a friend, in like 5 minutes versus 20 minutes or 30 minutes.
Yeah, definitely. I mean, of course, the elephant in the room here, right, is being able to create the desktop experience using these devices, right? Like if each person at the table has a smartphone, and there's a tablet, or maybe even 2 tablets in the center of the table, there's no reason why you couldn't, recreate the same exact experience just with, electronically. Like in the sense that like the phones would just have the cards that you'd be holding.
But that's like the world's most expensive board game.
Oh, yeah. You have to assume that people already have all of this stuff. Otherwise, it breaks down. But
yeah.
The thing is, your point is valid that like it's true. When we do the pass and play, we're not talking quite as much as when we're playing the board game. But I think that's more just a fact of you just have to kind of keep passing it back and forth. It's not like really like a board game where, it's just kind of always there. And it always feels like one person has to be paying attention. Versus a board game, everyone can step away, right?
Yeah. I don't know. But they have pros and cons. I don't think they replace each other, but I like to have them both.
Yeah, it makes sense. I mean, for more complex games like, what is that? Agricola, with all those pieces and putting the fences and the pigs and dealing with all that. It's like that would be so much easier. And then computing the score at the end always took like 20 minutes,
That's true. So what you need is an app where you just take a picture of the configuration of the board at the end, and then it scores it for you.
Yeah, definitely. Yeah.
Or like if you're really bad at chess, you have like a chess app that you like take a picture of the chessboard and it recommends the next move for you.
That'd be awesome. So
when the guy you're playing, sneezes, you just like whip it out real quick, take a picture, and.
Have you seen this where anyone can beat a grandmaster in chess just by having like 2 grandmasters in a room and the person playing the, opposite grandmaster's move? Anyways, you know what I mean? Like you have 2 grandmasters, you're playing both of them. The one on the right makes a move, and you make the same move to the one on the left. Like eventually, you'll win one of those games.
You'll win one of the 2 games against a grandmaster.
Yeah, exactly. Yeah.
Okay. Yes.
So yeah.
Okay.
A pretty cool thing is just we'll get off the subject is Vassal. It's kind of clunky. I wouldn't recommend it unless you got a little bit of techie skills.
Wait, they're listening to our podcast.
Yeah. Well, I guess what I'm saying is don't recommend this to your friends who don't know anything about programming or anything like that. Because most people would want to play this with other people. And so if you want to play this with other people, you'll probably have to go to their house and set this up, which is kind of unfortunate. But it's pretty cool. It lets you play over the internet. And basically what they've done is they have a bunch of board games, like probably 100-something board games. And they literally have just taken pictures of all the cards and the board and all the pieces. And they don't have any of the game logic in Vassal, but they just have the resources. So in other words, if you're playing Monopoly like on Vassal, you can just put a house anywhere on the board. It's as if you're really playing a board game. I mean, there's nothing stopping you from physically putting a house somewhere, even if it doesn't make any sense, right? So it's very open-ended, and it supports many different games, and you have to kind of enforce the rules yourself. But it does let you play a ton of board games online, which I think is pretty interesting.
Nice.
Yeah.
All right. I'm going to have to check that out. I haven't tried that before.
Yeah, totally.
All right, so on to the news. Our first news topic seems to have been very controversial online, and that is this new product called Coin, which is at onlycoin.com.
Yep.
Where Coin is a revolutionary new credit card device, or just card device, I guess. And the idea is that it is a small electronic thing that is the same exact size as a normal credit card, rewards card, driver's license, this kind of thing. And on your phone, you take a picture of the front and back of the card, and then you run it through a little card reader that they send to you. Similar if you've ever seen like the Square device is what I imagine it being, because it's not out yet. You swipe it, then it kind of knows what's on the magnetic stripe, and it has pictures of the front and back. Then you can sync from your phone via Bluetooth to this device, and have up to, I think it says 8 cards, where at the push of a button on the front, there's a little screen embedded. And when you push button, you can cycle through your cards. And then if you want to use your debit card, you select the debit card and swipe. If you want to use your credit card, you punch this button again, and it's your credit card, and you can swipe.
So how does this? What's the connection between this and the phone?
So the idea is that the phone is needed because if somebody wants to see that you actually own the card, I guess, and also that prove you have the card, then you want to have that on the phone. Also, the phone is what's used to transmit the details of what the card, like how to be that card.
Oh, right. I see what you're saying.
Right. So on the magnet, I don't know that much about it, but like the magnetic swipe of these cards, like the strip on the back, that the dark color typically has magnetic particles that are, I don't think they're encoded or encrypted very well. Encoded somehow, but they're not encrypted very strongly.
Right.
And basically when you swipe it, some pattern comes off that is like the card number, what the card is, and your name and your billing address or something. Like
and probably
just a few
CVV
items.
or something as well, right?
The what?
The CVV, those 3 numbers.
Oh, yeah. Or maybe, and like the expiration date, but like just a string. And so if you have a mag reader, like Square or something else, you can basically just get clear text, basically what's on the front of the card by just swiping.
Right.
So this device presumably will reprogram the magnetic stripe to whatever you've selected when you push the button. And then when you swipe it through, the reader will just think that card was swiped through.
That's awesome.
So
did they say anything about how much it'll cost or anything?
So I forgot now.
I'm on the website now. You can pre-order. If you pre-order, it's $55. If once it is launched, that it's $105.
Oh, okay. So it seems really interesting, but people have like a lot of concerns, I guess, legitimate or not. But that has like it seems pretty legitimate. Like it doesn't seem like a obvious scam. It's backed by some pretty big companies and VC firms, and weird thing is that they require you to prepay your pre-order. So this is slightly similar to Kickstarter, but like if Kickstarter doesn't succeed, you don't pay. But if it does, then you pay and eventually get your item. But normally when you pre-order something, you pay when it ships. But here they're collecting it up front. So you pay now so they can do all their manufacturing. And it doesn't, as far as I can tell, they have prototypes, but it doesn't exist yet, right?
Right.
So as with anything, there's a risk. And there's also a risk that, if you go to a restaurant and the person takes your card, like they could, in theory, switch to a different card on purpose or by accident.
Yeah, but that doesn't help them any, or does it?
No, but people have these, and also accepting it, right? Like, I don't know what this is. This isn't Visa or MasterCard. Like,
oh, that's
where
true.
do I? So there's just it'll be, at least initially, there'll be a lot of uncertainty from people. But it would be nice to get rid of all the extra cards, right? And just carry one.
Oh, yeah, actually,
card.
You're absolutely right. Think about this. Your debit card, as everyone knows, is much less secure than a credit card. It's actually very hard to reverse a transaction on your debit card, whereas it's almost trivial on a credit card. So somebody could, say at a restaurant, artificially add to your bill, somehow scam you that way, and then switch it to your debit card, and you know what I mean? And then it would be harder to get your money back.
Yeah, so that's one concern. They have some nifty safety features, like if the card gets too far away from your phone, it could auto disable or send an alert to your phone so that
nice.
You knew, that's a cool feature.
I guess that's true. If they have the phone can always there could always have a button that says, lock my card. So
yeah, that's what I was thinking, like a valet mode or whatever.
So they could
disable
swipe
card
it,
from changing.
Either disable it completely or just disable. Yeah, like you said, disable it from changing.
But
exactly.
One of the things, so there's been other startups that are attempting to do similar style things, and some of them it's by essentially you swipe one card and then they hold some pool of money, and then you can select on kind of the back end what card you want it to go to. Which is a very different thing and has other problems. But one of the nice things about that is that website can then track all of your purchases across all of your cards. Versus this coin thing, you can't track your purchases because it knows it got swiped, but it doesn't, for instance, know how much money was charged because they're not a part of the actual transaction.
Yeah, that makes sense.
So we'll see. It's definitely interesting. I like to see people innovating in this area because the current credit card stuff isn't that great. So
Yeah, right, definitely. Yeah, I mean, you think about it, if they get this right, you almost don't need a wallet anymore. I mean, if you get it down to only needing 2 cards, maybe there's like a better, carrying, utensil for that, right? I mean, the wallet in general.
But where am I going to put the pictures of my kids?
On your phone.
Oh.
Okay.
Yeah,
So
okay, that works.
the next news article, Dart turns 1.0. So we talked about Dart. I believe we did a whole show on Dart. Pretty sure.
Yes.
Yeah. And, we're both big fans. I'm a very big fan. I think Dart is amazing. I have had to write a lot of JavaScript. And I found recently there's some good tools that make JavaScript a little easier. In terms of, there's a tool called Typecast, which is pretty nice. I think we might have talked about it. But Dart kind of gives you a lot of these things, and it gives you a really nice set of batteries, as we always say. There's plenty of batteries included in Dart, such as, hash maps and lists and all these great things. Even like, tree sets, ordered maps, etc. So it turns 1.0, which is pretty awesome. This article that we've linked to talks a lot about the different features of Dart. The common criticism of Dart is that it just doesn't have that widespread adoption. I mean, it has this critical mass problem, right? Where you have just so much infrastructure built in JavaScript. And even though Dart 1.0 makes it much easier to access JavaScript code from Dart, it still is just, it's incredible. There's an incredible amount of inertia to move people off of JavaScript. I mean, it doesn't matter what the alternative would be. I mean, if you look at popular alternatives to JavaScript, they are almost always just small enhancements to JavaScript, like TypeScript, which compiles to JavaScript, CoffeeScript, which compiles to JavaScript, so on and so forth. So this is pretty difficult, but I believe strongly this is just a really great language, and we'll hopefully see it continue to get adoption.
Are there any other browsers besides Chrome that can run Dart natively yet?
I don't think so. And in fact, you can't run Dart natively in Chrome either.
Oh.
So, yeah, there's a special version of Chrome that you can download which does let you run Dart natively. But for one reason or another, it's still not part of the regular Chrome.
Okay.
Yeah, so there's actually no browser which lets you do that. But looking right now to see if I don't think that Firefox or any of the.
So it says that so currently when you part of the Dart software development kit is a version of Chromium that runs
Dartium.
Dart.
Yeah.
Oh, a version of Chromium. I see. Okay.
Oh yeah, right.
I misread.
Right, no worries. But yeah, the I don't really know why. I mean, I could only guess that maybe like they're having trouble with mobile or something. I have no idea. But so to finish that thought, you can convert your Dart code to JavaScript using this thing called Dart to JS, and then it will run in any modern browser. So
Nice.
Yeah, very cool.
So the next article we have is a successful ability of a qubit to last for 39 minutes.
So is that the guy?
I hear a round of applause.
Is that the guy who jumps from block to block, changing the colors and swears when he gets hit?
Wait, that's Qbert, isn't it?
Oh, you're absolutely right.
Yeah, close, but not quite. So a qubit is the name for a quantum bit, and I'm probably going to butcher this because I've always wanted to learn more about quantum computing and computers and have never successfully managed to make heads or tails of it. Okay. But so if you have a normal bit, it can be 0 or 1. But in quantum physics and in quantum events, you can have things that are not just unknown, like you don't know if there's 0 and 1, but actually exist in both 0 and 1 with some probability.
Right.
And so if you have that, it's called a superposition. So it's unknown. And it's really easy for something to interact with this particle or this qubit that is in this superposition to interact with it. And then once something interacts with it, essentially you've made a measurement of what the state actually is, and the superposition collapses, and now you have an actual either 0 or 1.
Yeah, so let me maybe
okay.
like
are you going to do better?
Up with
All right, here we go.
No, well, I'll just come up with it. So a lot of people don't understand quantum mechanics, and someone explained it to me in a way that's kind of morbid, but actually made a lot of sense to me. Is like, let's say you completely cut off ties to, say, your grandmother, for example, right? Assuming your grandmother is alive, then as soon as you do that, your grandmother is like 99.99% alive, but like some small like epsilon, like 0.0001% dead. Like she's in the superposition state where she's part dead because you don't know if she's alive or dead. Now, if you never speak to your grandmother for, let's say, 80 years, and let's say, assume you're young enough where you can live 80 years and still be around, then your grandmother, you don't know that she's dead, but she's in a new superposition state where she's, 99.999% dead and, some small percent alive, right? Because most people don't live to whatever she would be, let's say 180, right? So extremely rare. So once you go and visit her or her grave or what have you, then you know immediately. And then, as Patrick said, the superposition state collapses, and now it's either 0 or 1. And so, but what the important thing here is that there's sort of like this gradient, right? So it's like it went from 99%, false, 0% true, and then over time it like slowly shifted to the opposite. And so this is what sort of quantum programming is all about. Is sort of taking advantage of the stochastic nature of various problems to create these superposition states. And then hopefully the end goal is to sort of observe these superposition states, multiple times, and then aggregate those results into an answer. So there's a lot of connections between, ideas of like, confidence and probabilities and these kind of things and the quantum world.
So there's this idea of like a actual quantum computer, which is like a current computer we have now, but does all the operations possible in parallel or something like this, right? Right? And you can do things really, really fast. And that's kind of like a general purpose computer. But they have now things that are claiming to do quantum computing, which is more like along like what Jason's saying, which is like if you take the traveling salesman problem and you represent the initial, state of the world, then you perform in a quantum fashion some set of operations, and then you get to the end and you have a whole bunch of possible outcomes, but some of them will be optimal, and you want to observe which ones those were by having tried a whole bunch in parallel. And that relies on needing this probability distribution at the end. But if things lost their superposition along the way, like something bad happened in the device and a accidental measurement was taken by another particle colliding with the qubit, then the operations at the end don't work out right.
Exactly.
And so you can know that something happened wrong, and but you don't know what the right answer would be. You just know that something bad happened. And exactly. So the important thing about having a qubit which lasted 39 minutes is that like at room temperature is the other thing, because typically you keep it really, really cold because things move slower. And so I'm probably butchering this, but like
no, the way
sense. I understand it is like at really cold things move slower, right? So it's easier to keep things from colliding with the particle. But at room temperature, things are zipping around,
right?
And so it's much more likely that a particle will collide with a qubit, or something will happen that will cause the position to collapse.
Right, exactly. I mean, so just to complete the thought, like if something collides with a qubit, that means you know where that qubit is. That means it's not in a superposition state. So
yeah, you've taken some measurement of it.
Right.
Whether you meant to or not.
Exactly.
Because you could then observe that particle, and yeah. Anyways.
It's sort of like, if you ever watch like the World Series of Poker, any of these poker, shows on television, and you see sort of the person's chance of winning, right? And then as soon as they draw a card, all of a sudden like it's like it goes from, 30, 70% to like 99-0 or something, right? So it's that kind of thing where if as soon as you see that card, all of the dynamics change. And so if you have a card on the table and you don't flip it over, now you're exposed to a wide variety of outcomes.
These things are all really fascinating and really interesting to me. I wish I had more time to understand it better and explain it better. But if you're interested, you should go read more about it.
Yeah, definitely. Yeah, maybe we should look into this, and next book of the show should be quantum. We should put the onus on ourselves to find some.
Or you should go watch every YouTube video about this, and then we can have an actual show, and you can just tell us about it.
yeah, exactly.
Okay.
So last story of the show, hacking Candy Crush. I thought this was totally awesome. Actually, the title's technically "Winning at Candy Crush," but it's pretty great. Basically, this guy who.
So what is Candy Crush?
Oh yeah, so Candy Crush is a online game that is built in Flash, but it uses JSON, XML, HTTP requests to send data to a server. So, for example, you play this game in Flash, you beat a level, and then it actually packages some information on how that level had progressed and terminated, sends that as a JSON string to the server. The server then sort of decides whether to give you a new level or to have you repeat the current level, etc. And sends that back to you, and then etc. And more things happen. So, the server actually will send you the content of the levels one at a time. So you don't actually have the complete game. But yet this person was able to pretend like he beat a level by sending the right JSON to the server, getting the new level content, and then repeating. And it's pretty awesome. Actually, the person's profile picture is just him, like, with this goofy grin, and he just seems like the perfect person to do something like this. And even if you read further down, the content is great, and the comments, he replies to almost all the comments, and it is pretty hilarious. Actually, the whole thread I thought was really amusing. So, if you want to see how to hack online games, this is pretty epic.
Or how not to design your online game.
Oh yeah, that's true. Yeah, there's this cool thing called encryption. I mean, but yeah.
And not trusting clients.
Yeah, exactly.
Because somebody could write a malicious client.
That's actually an extremely good point. I mean, for people who are designing, any kind of server-side apps, you have to expect your client to do, one thing is, if you encrypt the string, then usually the decryption algorithm will just bomb out, right? But if you're not doing anything like that, yeah, you at least want to make sure that the person's doing something sane. There was actually a fascinating article, I'll see if I can find it, for another episode, where all about sort of the arms race between Chinese hackers who were hacking World of Warcraft so that they could get loot and sell it for real money, and the World of Warcraft security team. And it's really interesting. Basically, they had a bunch of they had a rule-based system where if any of the rules fired, they had a human evaluate the activity and then ban the account. So one of the rules, for example, was if you moved more than, say, 1,000 strides in less than a second or something like that, right? Then they fired some rule saying this person's doing something which isn't physically possible in the game, right? And these guys got around the rule they started reverse engineering the rules after getting so many accounts banned, and they'd moved 999 units, and then wait a second, and they had scripts which did that. And so I know the whole thing was really interesting. I'll see if I can pull it up.
So this is actually really common. This is a whole thing. I was reading something similar about when you can take your Xbox 360 controller and modify the electrical contacts where the button presses happen to have rapid fire, right? So everybody's probably seen these, on old consoles, you could buy rapid fire game pads.
Yeah,
and
right.
Instead of when you push the button, it just making one electrical connection, it would sit there and make it, break it, make it, break it, make it, break it, and give you rapid fire. But that you could use that to cheat in some games. And so they actually tried to detect on the server side for online play. For local play, they don't really care. But for online play and people gaming the system to get better rankings, they tried to do things like detect the distance between key presses, the time between key presses. There we go. And so if you're pressing too regularly, and fast, then they know you must be cheating, right? And so then they can ban you. So then the people who did these illegal mods to the controllers had to embed little microcontrollers which would vary the timing so that it looked human enough and be just fast enough that it was helpful, but not too fast that you would get caught.
Gotcha. That's
so
they
yeah,
had some Gaussian noise or something to the clicks so that they weren't all.
But it's crazy that people would
something.
spend time doing this, right? Like making microcontrollers and then selling them. And I wonder if it's profitable. I have no idea.
Yeah, who knows? I mean, I remember at one point I had a mouse where you could hit the button. There was a button you could hit on the mouse that would make the scroll wheel have no friction, and you could just spin it indefinitely, and it would just keep spinning. So I used this button, and then I bound the mouse wheel to like firing a pistol in Counter-Strike. And that was pretty fun. But I mean, that was a long time ago. I bet you get banned for that now. All right. So enough about hacking video games. So now we're doing the book of the show. My book of the show is Mahout in Action, which is, there's many of these in action series of books. Mahout, I believe we talked about it in the one of the machine learning podcasts, but Mahout is a machine learning suite of algorithms. Some of them run on Hadoop, which is, as we talked about, like a MapReduce framework. Some of them actually just are meant to run on a single machine. So if you just have, a machine sitting around, or just, you want to do some coding, you can actually use the algorithms in Mahout without having to set up, a bunch of nodes, a bunch of clusters, or anything kind of complicated. So I've recently been using this a lot. It's pretty awesome. It has a bit of a learning curve, Mahout does, which is why this book is so great. It actually walks you through how to use many of the algorithms in Mahout. And I feel like it's a pretty good read. I'm not all the way through yet, but I'm pretty happy with what I've read so far.
So you're recommending a book when you don't know the ending?
Yeah. I have a feeling it ends with in the appendix. That's spoiler.
But what if it's a cliffhanger?
Check out our book 2. Actually, I found
Or what if there's a microtransaction at the end of the book? You can't read the last chapter until you pay $5 more.
Yeah. They actually have that. It's kind of sad. But my wife was reading a free book from the Play Store. And sure enough, a few chapters in, it was like, oh, why don't you do an in-app or, in-book transaction to get the rest of the book? I was like, that sucks. That's pretty devastating. I mean, they should at least tell you. Maybe they did.
Yeah. If they're upfront about it, it's like, oh, this book isn't free, but we give you the first 3 chapters for free.
Yeah, they might have said that, but it's, in that small text that nobody ever reads.
Oh, okay. Or at least your wife doesn't read.
Yeah, exactly. Yeah.
Oh, all right. So my book is Bebop to the Boolean Boogie.
That sounds awesome.
And if you could say that 5 times fast, I will give you a thumbs up. So this is in theme with our episode topic. And it was a book I read actually many years ago. I think I might have found it at the library. I'm not sure where I found it at. And it was before I had taken up much programming. And it describes, just like it's saying, it doesn't actually say, but Boolean Boogie. It's talking about a lot about Boolean logic, and specifically about Boolean logic in reference to how it would be used in circuits.
Oh, wait. So this isn't like a fiction, like sci-fi book or something?
No.
Oh, okay. Sorry.
I have a legitimate, actual, useful book this time.
No, it's not a dig on you. I saw the title and I just thought for sure this was a sci-fi book.
So why it attracted to me when I guess I was in probably middle school or early high school was that, so it's a really fun approach. So similar to the recommendation of the design patterns book, Headfirst Design Patterns, it takes a, somewhat lighthearted approach to design patterns, but it is a serious learning. It's just like you do learn the design patterns that they go over. This is very similar. It takes a lighthearted approach.
Yeah, it got some really good reviews on Amazon and a couple other websites. So yeah, it looks pretty awesome. I'll definitely. Yeah. It actually got a perfect 5 stars with on Amazon. So
yeah, that's pretty awesome. So I'm vaguely remembering it from a long time ago, and this cover isn't the cover that I remember seeing. So I'm sure there's a new edition now or something.
Okay.
But yeah, so it goes over, like, if you're new to programming especially, it could be helpful. Or if you're interested in, so a lot of people talk about, like, circuits and electronics and electrical engineering. And so there's analog stuff and digital stuff. And to do any, digital stuff, you're going to get into kind of Boolean logic and learning about that kind of stuff. And we'll go over that. Like, what is an AND gate and how does it function? What is an OR gate? How does it function? What about exclusive OR? How do you count in binary? How do you do binary math at like a gate level? How do you do like how do you call them cardinal maps or whatever? Like optimizing what's called a truth table. So like you have inputs that are either 0 or 1 and you have many of them, and here's the outputs you want for each set of inputs. How would you devise a set of gates to do that? And so this will come into play. We'll talk about this maybe more in a little bit later in the episode. But this book goes over that, and it does it in a lighthearted and fun way that I remember being fond of when I was younger. Not that you have to be young to read it. I'm sure it's equally fun now, and I should bring it back out and read it again. But that's my recommendation.
Cool. Yeah, it sounds awesome. I'll give it a go.
All right. Tool of the show.
Tool of the show. So my tool of the show is actually a website. It's Kaggle, Kaggle. And it's pretty amazing. So basically, so Kaggle is a data science competition website. And so, it's funny, a lot of people don't really know what, a data scientist is or what that even means. I mean, they think it's someone with like a lab coat who like mixes data from one file to another. And so this is pretty interesting. The site has a handful of competitions that are fake competitions meant to sort of teach you about data science, which I think is extremely extraordinary because it really sort of like helps you understand that it's not about programming in a certain language or something like that. It really sort of tells you it gives you a list of sort of data science problems and then walks you through several solutions, which is pretty great. Now they also have serious competitions with real rewards. And the way it works is they provide you with a data set. So there's a competition going on right now where they provide you with a bunch of data from Stack Exchange. So Stack Exchange is the sort of mothership for Stack Overflow, Math Exchange, and all these other websites where you can ask questions, right? So people generally tag their questions. So you might ask a question like, I keep getting this Java runtime exception, and then you tag the question Java so that people looking to answer questions will be able to do filtering, right? So so Kaggle has a competition where they give you a bunch of questions with the tags, and then they give you another set called the test set of questions, but you don't know what the tags are. So you are supposed to produce the tags for that test set, and then send your predicted tags to their server, and they will score them and give you a score back. And the goal is to get the highest score. So all of these have a deadline, each of these competitions, and the scores are pretty awesome. Like here's one flight. One thing too about these competitions, I don't know for a fact, but I believe pretty strongly that the people that are posting these competitions have like a vested interest in the algorithms.
Well, considering the reward for this one's like, what does it say, $200,000? Yeah. I'm pretty sure somebody has a vested interest in it.
Yeah, so General Electric, I guess that's who this is, right? They are offering $220,000 for somebody who can solve this data set as completely as possible over the next 30 days. That's actually pretty extraordinary. Most of the rewards are pretty small. Actually, Facebook has a competition, and the reward is allegedly a job at Facebook, which is, I think, pretty interesting. But most of the time the rewards are $5,000 or something. The ones where the rewards are knowledge, that's sort of a special case. That means these are ones that are meant to teach you data science and how to be a data scientist.
Nice. So is it the case that like this GE one or whatever, I didn't read it, but like is it the case some of these like they require like what was that, the Netflix prize was a while back, like they require a certain threshold of embetterment to be reached before they award a prize, or somebody will get the prize at the end of this time period?
Yeah, that's a really good point. So if you look at the leaderboard for any of these competitions, they actually have some special spots on the leaderboard which denote sort of milestones, and they expect all of those milestones to be completed. Like, for example, looking at the GE one, they had a sample submission benchmark, and I guess you have to do, if you don't do better than the benchmark, then you won't get an award. Like for example, the Stack Exchange, their benchmark is they pick the 4 most popular tags and see if it's any one of those. And if you can't do better than that, then if no one can do better than that, then no one gets a prize.
Oh, okay.
But from the competitions that I've seen thus far, every one of the competitions has been won by somebody.
Okay.
So yeah, it's pretty interesting. I mean, I don't know sort of how competitive it is. Anytime you have something like this with the whole internet involved, you have to expect that you'll get the best and the brightest. And so, although they're offering this $220,000, I wouldn't go in there expecting to win it or wanting to win it. I'm sure there's like whole armies of people who are working on this, but it's still phenomenally cool to work on this or on any of these and get some good results and test if nothing else, it's more data for you to test your system on,
Well, test your system on, learn these techniques, and like I'm sure this kind of thing is, even if people don't know what this site is when you go for a job or to change jobs, that it'll let you talk about things very confidently, and you can point people to like, oh, here's stuff I did, like I did these type of analyses.
Yeah, exactly. There's also a forum for each of these competitions, and you can post, you can answer questions, ask questions, etc. On the forum, and I think it's phenomenally interesting. I definitely recommend everyone check it out.
That's awesome.
Yeah, and there's 34 days to go on the Facebook recruiting competition.
So by the time you hear this, you're not going to have much left.
Yeah.
No, I'm just kidding.
Yeah, so these competitions are actually pretty interesting. Yandex, which I believe is the Russian search engine, is offering $9,000 to somehow like do a better job ranking given the personal preferences of the users. I don't know. I think this stuff is really interesting, and it's pretty cool that the data is right there for you to access. It's like usually you have to go scraping Wikipedia or doing something painful to get data, but here's just a bunch of really awesome data just waiting to be downloaded. So
cool.
Yeah, definitely. So now we're on to FPGAs.
Wait, we're skipping my tool of the week? Okay.
Oh man, I'm so sorry.
So
they both started with K, and I think I don't know, my eyes just skipped it.
It's okay. So my tool of the week is KiCad or KiCad. I don't know how you pronounce it. KiCad.
Okay.
And this is a tool, again, in theme with the show. How apropos. That rhymed. Is a tool for designing electrical circuits and building PCBs, printed circuit boards. So if you're going to make your own circuit, which if you get involved in any kind of hardware, microprocessor stuff, you'll eventually kind of want to do. This is an open source tool that's free, no limitations, and lets you kind of lay out, I want to have a resistor, and I want to have this processor chip, and I want to have these inputs and outputs, and plop them down, arrange them, connect them up, and then build a board that would represent that schematic. And that's something that's normally done by very expensive software. So a lot of people use this tool called like Eagle, or there's another one, I think it's called Altium. But these are like very expensive, like thousands of dollars to have these boards. And people use these to build like the motherboard in your computer, right? So like, I need slots for RAM and a slot for this processor, and I need these ports over here and this north bridge. And it's like all those things get laid out and may have like, 4 layers of different planes of circuit copper in the single board that is your motherboard, or 6, or I don't even know how many are in a motherboard.
Okay.
But I don't want to learn any of that. That sounds way too complicated. But I have been doing some projects like with an Arduino. We've talked about Arduino before, or Raspberry Pi. And you want to like connect things together, and you don't want to have to use little wires. You could use a tool like this and either make your own printed circuit board, which is something I actually want to try to do sometime, or send it to a company. So I actually did this before. I had a RGB LED that, so it's one LED device, but it has 3 LEDs embedded inside of it, one red, one green, one blue, so you can make it any color you want. And I made a little circuit board that's like an inch square or less, and connects pins so you can plug it in on a breadboard to the pins of the LED, which didn't fit on a breadboard well. And so I was able to design that in the tool and ship it off to a company, and then they sent it back to me, my little PCBs, and I got like 3 of them from this place. And
how much did that cost?
It's like $3.
Wow! So you can
crazy.
basically you can make like a single board computer that does something relatively simple for $20 or something.
So it depends. Like, it's based on the size of the board you need, how many layers you need. It gets complicated really fast. But if you don't know about this tool, it's cool. You should check it out. This one's open source, and so you don't run into limitation of size. So some of the other ones are limited, like you can't go bigger than 3 inches by 2 inches. And if you do, then like you'd have to pay. But if you're designing something simple and only having like one surface, you might want to make something actually pretty big that you could do yourself, and you couldn't use that tool. So when I've been teaching myself this stuff, I wanted to do it on something where I wouldn't ever have to worry about running into some limitation and feeling bad because I'm not going to spend thousands of dollars to buy the tool.
Yeah, right, definitely. This is super interesting. It's actually, I love these OLO stats. They're on many different open source sites, but it says that it's 585,000 lines of code in KiCad. So I don't know. I don't know what that's doing, but is doing. There's a lot of effort there. So
there's a lot of things around like automatically routing the little electrical paths and stuff like that. It's pretty cool. You should check it out. And actually, recently CERN got involved with the project, and they want to use it for doing a lot of their circuit designs, and so they're starting to contribute to the project.
Oh, very, very cool. This is super interesting.
Yeah, check it out.
How do you deal with like? So I noticed on the picture here it has like a physical switch and a physical serial, serial out. How do you? I mean, the company that you send the schematic to, do they do the switch part too and everything?
No, so typically you decide in advance, like I want a switch, and then there's like common switches, or they may have it in a library, or you may, specify it yourself based on the data sheet of the switch that you've picked out, and then when you get it back, there are companies which will populate the board for you, like go ahead and solder everything on. But that's typically much more expensive. I've never even looked into that. But basically what I do is like, I have these common parts already around, and I've made some example circuit, and I just want to put it on a, board. And so you solder it on yourself. So in advance, like I have this switch, and you drop it on.
So you take a few of the parts from your nuclear submarine that you used to hunt for Superman's body and use that to build your next project.
I'm going to say yes. But I don't know what you just said.
Oh, man.
But yeah, awesome. Check it out. If you're into hardware, it's pretty cool. You probably already know about it. And if you don't, and it strikes your interest, or the things I said pique your interest, you should look into it.
One more thing on this, and then I'll let you off the hook. But where do you go to buy the things like switches, like very basic things like this? Like switches, motors. So how do you get any of that?
Yeah, so the internet, of course, that's one answer.
Okay.
So most of the electronics, so it's actually kind of difficult. So there's a couple, like you'll learn about like these places, DigiKey, Mouser, Element 14. Like there's like different places you'll learn about, and maybe we can talk more about this in another episode, because it's actually really fascinating. I'm really into this presently. But yeah, so like there's websites like that, but they serve like people who are literally doing this for a job, right? Like building motherboards or building the electronics that go into cars or just TVs, anything, right? And so they're getting parts for them. And they just literally, if you search for like a resistor, they'll have a million different kinds of resistors. Well, that's really overwhelming. So then there are other places like SparkFun that are more hobbyist oriented, where they have the most common ones. Like, we know you'll probably want this. Like, this is the most basic switch. If you just need a switch, just choose this switch.
So you could go to SparkFun, like find a few things, and then go to DigiKey to like complete the collection or something.
Yeah, like if they didn't have something. And then you can also go, there's local electronics stores. So there's like a place here specifically that I've gone to in the Bay Area of California that has like what they call surplus electronics. So companies go out of business, or there's like old equipment and they sell it to this place, and then they allow you to come in and you can buy stuff really cheap. And they just have like bins and bins of resistors and, various capacitors. Yeah, it's actually awesome to go to. It's
oh my gosh,
really cool.
We got to go.
Okay.
Are you? Is it baby safe? Like if we were holding the baby?
No.
No, he would reach out and electrocute himself or something.
Well, not electrocute, but like swallow. It's tons of tiny components, right?
Oh yeah. All right, we'll have to find some time to do this. This sounds pretty epic.
Okay, it is pretty cool. It's a lot of fun. So anyways, so on to FPGAs.
Yeah, FPGA. So I think I know. So of course, just some background. I did almost entirely theoretical computer science, and Patrick majored in computer engineering. And as a result, I am a complete Luddite when it comes to any of this. But I know a few things, and I will try my best to keep up. So FPGA is programmable gate array. What's the F?
Field.
Oh yeah, field programmable gate array, and I'll let you take it from there.
So this is going to be an interesting topic. We'll talk a little bit about programming because programming FPGAs is kind of interesting and different, but also just about like how FPGAs may interact with processors. So if you're ever doing any what's called embedded systems programming, you'll often deal with FPGAs or can deal with FPGAs at a company. So they're very common in a lot of commercial applications, or just depending on what you're trying to do, you may come across it, and it's good to know because you'll see it out there and people talking about it if you're doing any non-theoretical or only high-level application programming. So a little bit of history is that so we talked a little bit and when we were talking about the book of the show about Boolean logic and AND gates and OR gates, and these are the things which kind of represent when you have like a 1 and a 0, and you want to say if both of them are true, do I want the output to be true? And so you have that Boolean logic, and you can use Boolean logic to describe ever growing complicated components. So with just a few AND and OR gates, you can describe a thing called a multiplexer. And a multiplexer says like, I have 5 different input lines, and I want to specify which of those 5 get put onto the output. Or I have 2 numbers into what's called registers, little bits of memory, and I want to add them together. So you can specify that with just a handful of AND and OR gates. And once you have all of those components defined, you can add those components together and actually build CPUs. So that's how a processor gets built, is from a collection of these digital gates. And in fact, there are a couple gates that can be used to make all other gates. So with only a single type of gate, you could actually build an entire CPU. And if you ever take any classes of it or follow any tutorials about this, it is actually really rewarding. One of the things I did when I was in school is start from those ANDs and OR gates and actually build up to a whole, I think we made a 4-bit processor. And you actually had memory and an instruction set, and you had to learn like what assembly programming really is about, and a little switch that you were at the clock. Like you would switch the switch up and down and actually clock the CPU. So it was like a 1 hertz 4-bit processor. And the final exam for the lab part of the class was actually the TA for the lab would bring in a piece of memory on a chip, plug it into your CPU that you had built, and you would sit there and clock it, and you would have LEDs that represented the output, and he would write down after 10 clicks of the clock like what the LEDs were, after 20, after 30, and then they had to be right in order for you to pass. And it represented the instructions actually being executed and the results being displayed. And you had no idea what was in his instruction set that was on his... You knew what the instruction set was because they gave it to you, but you didn't know what specific program he had just run on your processor.
Oh, I see.
So
yeah, so I think, and correct me if I'm wrong, I think the reason why one would want to program their own FPGA is because when you work with just a regular processor, you're doing things in serial, and the processor can do anything you want. It can do multiplication, add, division, many other operations, but it's designed to do any of those, and it's not really balanced one way or the other. Or I guess it is balanced. It's not biased one way or the other. And so if you need to do 40 add operations, they're just all going to queue up one after another. Now the processor will try to do like out of order execution. Processors have gotten very complex, but the reality is, if you need to add an entire array of numbers at once, that's the way your program is designed, or the algorithm you want to create is designed. Then with an FPGA, you can literally have 8 copies of the add mechanic all running at the same time.
Yeah, so that's like a really good idea. So like if you have like a 32-bit processor and you want to add two 64-bit numbers, right? So the 32-bit processor there means like the width of the data coming through this is a lot of hand waving, but basically that you can have 32 bits per number and you can add two of those numbers together. But you have 64-bit numbers. Well, that means you have to do the adding twice, once for each pairing. But like you said, you could in an FPGA have 256-bit adding, so add 256 bits twice at one time. And if you wanted to do custom things like, I want to multiply this, add it to the previous result, and also do this other custom thing that's only to me. A processor won't have that special logic. Processors sometimes do have specialized logic if it's not too specialized and they think it's useful to everyone. But an FPGA can have whatever logic you want. So it can do custom things that are crazy and don't make sense and do them all in parallel all at once. Because there isn't, the way the clocking works, it isn't like this thing feeds to that thing, feeds to that thing, feeds to that thing by necessity. It can just be like, I want to do all this stuff at once, all at the same time.
Yeah, exactly.
And so that is the reason why you would, have an FPGA. And it's going to get a little, that we could go into like a lot of the history and stuff and ways of representing it, but I think I'm actually going to skip over it because I think it'll end up being kind of boring.
Yeah, one other thing I'll mention about the FPGA is that it saves a lot of power, right? I mean, as we talked about, the processor is a general purpose machine that has many, many different instructions, and it's actually extremely complex and has what's called a pipeline where it can be working on several instructions at the same time. But if you're working on, building a phone or a small device that, you want to put in your car or something like that, then power becomes an issue. And so, writing your stuff in FPGA might make the difference between something running for an hour on battery or 4 hours or longer, right?
Yeah, and there's other things that, processors just don't do good at, because the idea with a processor is it's like set, like whatever gates they put into a processor, because processors and FPGAs are both kind of gates fundamentally. Whatever they put into a processor, they select one set of gates, and that's all you get. And so they have to optimize for a lot of cases so they can sell it to a lot of people, and they don't know what you're going to do. But the FPGA is just the raw collection of gates. So you could take that collection of gates and build the same processor in it. And they actually do that. It's called like a soft core. So you can take an ARM processor like is in your cell phone and manifest it in an FPGA. So arrange the collection of gates in an FPGA to be an ARM processor. And if you want like extra floating point ability, you could add it in. If you wanted extra like an extra wide pipeline, you could add that part in or take parts out. And you can.
Interesting.
That's what the field programmable part is about. Is like in the field, not in the factory. Like you can change the combination of gates, so you can bring in and drop out your own processor, or even things which we wouldn't normally do in a processor.
I always wondered where the field came from, and that makes sense. Like the field as opposed to the factory. I like that.
So we can get into it's a long discussion talking about like the kind of actual like engineering things behind this and what happens. But you can define like an FPGA to do any kind of things you might want to do in a processor or things which you wouldn't want to do in a processor. And the ways that you kind of program them, like write the programs, one is we were talking about like logic gates, and logic gates have symbols, and you can kind of draw a circuit, a schematic that describes what you want the FPGA to do. So like I want it to look at switch number 1 and switch number 2. So like switch being like, as an example, like a light switch. So I only want to turn on the lights in my living room if both light switch 1 is on and light switch 2 is on. So I have an AND gate that looks at light switch 1 and light switch 2, ANDs them together, and the output goes to determine if the light is going to be on or off. And you could draw a little picture of that, and the FPGA would be able to replicate that logic. But as you get to bigger and bigger and bigger and bigger devices and more complex logic, those gates become like even worse than writing an assembly code, like even lower level.
Yeah.
So then what they have is some sort of what they call hardware definition language. So you'll hear VHDL or Verilog. And VHDL and Verilog are, without getting into specifics on there, ways of describing how the FPGA should function and how things should have, like you could use that. I want to add what's in place number 1 to place number 2 when the clock ticks. So every time the clock ticks, whatever's in location 1 and location 2, add them together and put them in location 3 every time I get a clock tick.
Oh, I see. So it implements the add operation, I guess, for you?
Right. So it determines how to configure the technology inside the FPGA to basically do the add operations every time you have a clock tick. So that's one of the things that's interesting about FPGAs versus processors, is that in FPGA, like, you have to talk about the clock. So in the processor, you talk about like, oh, my clock speed is 16 megahertz or 1 gigahertz. And that means that like an operation that completes in one cycle completes in one millionth of a second for a megahertz. And I can count how long a certain set of operations will take. So if you need to do something really fast, you need to know how long each instruction takes. Well, in FPGA, it's even more prevalent that you have to think about clocks and how fast your clock is running, and that each time the clock ticks, because you're kind of defining this pipeline, like a step A, I want to do this, step B, I want to do this, and step C, I want to do this. So every time the clock ticks, things are moving down the pipeline, but the next set of things are coming in right behind them. And that's for what you call kind of like streaming operations. So FPGAs are used heavily in streaming operations. Like if you imagine a video camera has data coming in every time it takes a picture. So a video camera is just taking lots of pictures, one right after the other. And those pictures just keep coming in and coming in and coming in and coming in. And in a processor, if you spend slightly too long processing one of those frames, all of a sudden all those other frames after you get pushed down the line and you end up with a problem. In an FPGA, you're defining that like I'm doing this, then this, then this, and those frames just keep feeding in. And it's doing the same thing pretty much every time. And
yeah, it can't really get backed up because there's no pipeline or buffer or anything.
Well, it's like
that.
but you defined it so strictly, right? So it's not like there's.
Oh, I see.
It's not like branching, right? Like, oh, if I see, the color blue, do this. If I see the color green, do this. You don't do those kinds of things in FPGA. An FPGA is much more about doing like a known set of operations. Like I want to, divide every pixel by, 3 and then add it to what the value of the previous pixel was. So it's kind of like you want to define that. And we talked previous about like GPU programming and how GPUs don't like having branches in them.
Right.
Because when you do general purpose GPU programming, the branches make it more difficult to do. And so FPGAs are similar in that regard. They're really good for when you know precisely what you want to do every time and you don't have a lot of complex logic and algorithm around it. So that talks about what it's really.
What about if you're writing this VHDL or Verilog so it sounds like you're almost writing arithmetic, like add these two registers and do this. How do you specify like these things can be done together, but this thing needs the other thing? I mean, does it figure out all the data dependencies for you?
So partly, right, you're defining, so you're defining like, oh, here's kind of like this component, and this component feeds into this component. So kind of like functions, right? So that's the equivalent. But it is a data flow language, right? So you're describing how the data flows through the system, and so you're describing that flow. And it is something kind of starkly different from writing an imperative program. It's much more functional programming kind of style.
Okay.
So the reason why like FPGAs are good is like we talked about that, doing things in parallel. So you have one processor, so you can add one set of numbers. But if you wanted to do like 10 of those at the same time, you might have like 10 cores in your processor, then you could do it. But like an FPGA, if you're doing some simple thing, you could just create 100 of these cores, where a core does some very basic operation over and over again, and you can just keep creating more and more and more of them. And so you can get that parallelism very easy. And for, like we said, certain sets of algorithms where it's very set to what you want to do, and you just want to compute it and you want to do it really fast and over and over and over again, taking time to implement that algorithm in an FPGA can get you a lot of speed. Gotcha.
Yeah, it also affects the power greatly. Like a lot of the smartphones now do MPEG decompression on not an FPGA, but on. Actually, how does that work? So if you write something in an FPGA, can you turn that into a processor?
Yes.
Okay.
Sort of.
Gotcha.
So a lot of those, they're called like co-processors you'll hear about. So like the MPEG encoder. So it could be that that's just like another normal processor, but more likely it's a very specialized processor that's called an ASIC. And I don't know what ASIC stands for actually. Something IC, which is integrated circuit.
I will look it up right now.
Okay. All right, good. So basically an ASIC, you can take an FPGA description, a VHDL description, and synthesize an FPGA, which means figure out how to take this field programmable, this reprogrammable set of gates that you can interlink in different ways to represent the logic that I've defined in my VHDL program. But by the same token, the tool could also say, take that set of logic and determine the set of masks you would need to make to etch away at the silicon to actually make a custom chip out of silicon that does that one specific thing.
Gotcha.
But
so
once
ASIC,
you do that...
ASIC stands for Application Specific Integrated Circuit, which I don't know what that means. You'll have to
application. So like I said, so it's like once you make an ASIC, that's it. Like you can't change it anymore. And it involves a lot of engineering costs to kind of determine how to go down to the actual gates and determine I only want these sets of gates, and it's not reconfigurable. And once you make it, that's it. And you use it for a specific purpose. And so that's probably what like that MPEG chip is about. So somebody wrote this description in VHDL of how to do a portion of the MPEG encoding process really, really fast. And then they actually went and had a specific silicon chip made that does just that. And then they put it in all the smartphones.
I see.
So an FPGA would be like the first step to that, like the prototyping step before moving to an ASIC. But it could also be that ASIC is too expensive for your need, and so you just continue to use an FPGA. So like an ASIC per unit, like per chip, would be a lot cheaper because it's doing, it's like made and only does one thing. But like the initial cost, like you'd have to buy thousands of chips.
I see.
You can't just go buy one.
So maybe this, going back to the first news story about Coin, I guess maybe they will, take this pre-order money that we give them and put the logic for switching the credit card numbers and things like that on ASIC.
Yeah, so they could.
Does that make sense? Mm-hmm. Okay.
I mean, I don't know that that's what they're doing, but it is like an example of what you could do.
Gotcha.
So
is ASIC much smaller than an FPGA that does the same thing? I mean, is it vastly different or is it about the same?
So yeah, I would say that like if you had an equivalent, how big of an FPGA do you need to hold a set of operations versus an ASIC? The ASIC's gonna be much smaller because the FPGA needs to have all this extra routing and switching logic to be able to be reconfigured. Gotcha. And you don't need that in the ASIC. You're hardwiring one specific configuration.
Okay.
So some of the things that make it difficult is this FPGA programming falls in kind of a weird space, right? So computer science people, like Jason was describing himself, would be very distraught to learn about all these details they had to pay attention to about clocking and interfacing with external power and those kind of things. And electrical engineers don't always enjoy programming. Some do. But some, don't really want to do programming. And so this FPGA programming falls in between those two disciplines. And sometimes it's hard to find people who want to or have the ability to do it. And it can be difficult sometimes to take the logic of like a C program and actually determine how to do the same thing with the constraints of FPGA programming and VHDL.
Gotcha. Yeah, I mean, to Patrick's point, right? Like, the reason why you'd want to do this in FPGA is to get some kind of like parallelism or speed benefit or something like that. So you can't just take your C program with the for loops and things like that and just put it directly into VHDL or Verilog because you lose all of your benefits. So when you go to something like an FPGA, you have to think about the data dependency. Like, can I do all iterations of this for loop at the same time? Or if I can only do part of them at the same time, how do I structure my operations so that I know they're finished in time for the next batch to start? Things like that.
Yep. And testing is pretty hard. So like I said, FPGAs, interface don't have like the processors handle interfacing with the outside world with all this specific logic. But like on an FPGA, they're meant to be used in different ways. And so often you have to worry about interfacing the outside world and determining the set of inputs you want to test against. So like, what happens if one of the inputs to your FPGA isn't 0 or 1, but is floating around? What happens to your algorithm, and how do you test that?
What does that mean? How could it not be 0 or 1?
So, okay, we'll get sidetracked, but it's okay for a second. So, like, if a processor, just for ease, is running at 5 volts, so you powered it with 5 volts, then when it sees a given pin it is called an input pin, if that pin is at ground, then it says it's a 0. If it's at 5 volts, it says it's 1. So that works really well. Digital says it needs to be either 0 or 1.
Right.
But what happens if you don't connect anything to that pin and the pin is just getting electromagnetic interference and it's varying from 0 volts to 8 volts to 2 volts to 6 volts?
Oh, you have to deal with that while you're programming
So like it could just be flapping around on you, right? Like, and typically because of the nature of the way FPGAs sometimes want to handle those kinds of things, you have to handle those kinds of things, versus like in a processor, people assume you don't want to handle those kinds of things. So they typically build the board such that it doesn't happen.
Gotcha.
Also the tools, like still there isn't really good like open source tools for programming FPGAs and synthesizing like what amounts to the compiler, the thing that takes your VHDL and determines here's how I would program a set of logic gates. And even like I looked around because I wanted to, as like a hobby, like really programs. I've done some FPGA programming in the past for work related stuff, but like as a hobby, like I wanted to do it. And the boards are typically pretty expensive to get one and actually, try it out. And the tools themselves are very expensive. So, thousands of dollars for these tools that compile these FPGA programs that you write. And often they're student versions or free versions. And there are even some tools, and I've used a couple of them before, very limitedly, where you actually can use a restricted set of C language to define an algorithm, and it'll synthesize the FPGA for you. So it'll take your C language, compile it to VHDL, and then take that VHDL and pass it into one of these tools.
Oh, wow.
That tool will make the FPGA. And those are getting better, and one day people hope that like you'll just be able to program an FPGA in C++.
But if you do that, how do you tell it that, that it should have, 3 add modules instead of
so there's
2?
special kind of preprocessor tags you add and say like kind of hash, pound in parallel 8 and then a for loop, right? So do 8 iterations of this for loop in parallel. I made that up, but like that would be an example of what you would do. Right.
Yeah, so you annotate your code to help.
Right.
That's pretty cool. Yeah, I'm looking around on shopping, Google Shopping. Yeah, it looks like it'll run you a few $100s to get FPGA, which actually isn't that bad.
No,
actually, they have some smaller ones that are sub $100.
So yeah, but versus like, I've played around with little microprocessors and writing C code like Arduino style, and you can get an Arduino for, $20, or the processor that is used on there you can get for like $1.30 or $1.50 or something.
Yeah, that's true.
So one of the interesting things is, a lot of times you pair an FPGA with a processor because they both have their advantages. And so you can either talk like, serial to the FPGA and communicate with it, or oftentimes what's interesting is when you go to a memory address in C, then you're actually setting some pins on a microprocessor to hold the address that you specified. So in binary, these pins will represent that address you specified. And then another set of pins will start taking on the values of the data you write to that address, for instance. So some of the memory you have is what's called internal memory. So when you do that, nothing will happen on those pins. You'll just write to internal RAM. But then other parts of the, address space, it's called, will map to these pins that are exposed on the outside of the processor. And when that happens, the FPGA could actually be sitting there. So one way you can talk to an FPGA is to say, like, at address 5000, when you put the number 3, I'm going to go turn this light on. And when you write the number 4, I'm going to go turn it off. And then you can actually talk to it by writing kind of specific values to specific addresses. And that's a lot you'll see common even when you write like device drivers are handled that way.
I always wondered this. If you if you try to set the pins that are connected to the output of an FPGA instruction, what happens then? I mean, does like the world collapse or?
No, it's handled. But yeah, like you got to be careful.
So what would happen? Like nothing would happen, I guess?
So like if I'm not actually sure what would happen. So if you had two output pins connected just to each other, they'll try to drive each other. So I guess one would win.
Oh, I see.
And so that would take on whatever value of one of them or some value in between. I don't remember.
Well, I guess maybe, sorry, the question I was asking is, can you go through an FPGA backwards? Like what happens if you, like instead of setting the input pins and then reading the output pins, if you set the output pins, what would happen? Would the electricity go backwards to the FPGA?
No.
Okay.
Typically, so it's configured where like the outputs are configured in one of three. A pin is configured in one of three states: to be an input, an output, or what's called disconnected, like a high impedance state where no matter what you do otherwise, it's not going to affect it. So when it's an input, it's trying to read the value. So anything can happen on the thing. When it's an output, if two things are an output, they'll compete, and typically there's circuitry built in to protect them from the current flowing backwards. But what happened, there's what's called contention on the line. So like whatever that piece of wire between the two it's undetermined whether it'll be a 0 or a 1, whether it'll be positive or ground.
Gotcha.
But yeah, they typically protect themselves from having current to flow backwards. That would be bad.
Yeah, right. Okay, that makes sense.
So like I said, a processor and an FPGA could be embedded together on a device. You can also have a version of the processor inside of an FPGA. So some part of the FPGA is currently representing a processor, and then other parts, other things.
Oh, interesting.
And that's called soft cores. And so you can embed like an ARM processor inside your FPGA. And now people even talk about doing things like if I enter different modes of operation, having a processor to load a different program, as it were, on the FPGA. So reprogram the FPGA in the middle of something to behave differently. So like,
oh wow!
So like
so you go to watch a video and the
right.
FPGA reprograms to be an MPEG decoder or something.
That's right. And now I'm recording a video, so it switches to be an MPEG encoder. And now I'm
awesome.
doing something else.
How come that isn't widespread? It sounds like an amazing idea.
I think it's just one of those very difficult things to do, like how to figure, like, not only do you have to program the FPGA once, now you have to like figure out the code for all these different ones, and then when to switch.
Gotcha.
And then it might just be easier, like as technology gets better and better, like instead of having reprogramming it between two different modes, you just have an FPGA that's twice as big, and then you can program it to be both at the same time.
Oh, true. That makes sense.
So, but people have talked about it, and there's some interesting stuff around that.
Well, this is very cool. So from what you've taught us, we should be able to go on DigiKey, buy some cool motors and electronics and FPGA, and go to town. That's pretty awesome. I might try this.
Yeah, this wasn't at our normal episode. Like, I didn't really go through the merits of VHDL or Verilog or how to program them.
It sounds like there aren't really any competition for these two, so...
Yeah, but hopefully spark some interest or explain what it is. A lot of people have heard the term FPGA and just don't know what it is or what it does or how it's different.
Yeah, definitely. This is awesome. I've always wanted to do something in the robotics space on my own, but I've never had the talent to do it. So maybe this will be even just something as simple as, like, if it could just go and open the fridge and get a sandwich. Like or something like that. Even if I have to tag the sandwich, just something very simple. It'd be fun to just do it for fun.
Yeah, that's still setting your sights a little high. Yes, I
really?
more amuse myself with getting an LED to blink on and off.
Yeah, I guess that's true. I should probably start there. Okay.
So.
All right.
Cool. Well, I think that's a show.
Yeah. Thanks a lot for helping carry this show. It's a really interesting topic. I thought it was awesome.
All right. And thanks for all our comments, people encouraging us to get back on our mics and record the next episode.
Yeah, definitely. It's pretty hard, right? Because, we've been going through a lot of changes. I actually work across town now. So it was a big transition for me. And actually, we installed Ticket to Ride in our house. And so we have trains going by constantly.
So now when I mute that audio, people aren't going to know what you're talking about.
Oh, tear. Okay. But we've had a lot of personal
trains
stuff.
are driving by my house. So.
Yeah. Now you can't mute it, not without everything being awkward. But yeah, so I've had a lot of personal stuff going on, but I appreciate everybody's patience, and we definitely have a lot of fun doing this show. I learn something brand new every show, and I'm sure you guys do too. So thanks for all the support, and have a good time.
All right, till next time.
If you build anything, you have to let us know. I want to see pictures.
All right. Bye.
See you later.
The intro music is AXO by Binar Pilot. Programming Throwdown is distributed under a Creative Commons Attribution Share-alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.